So hello everyone, let's continue with the yesterday's question. So this was yesterday's question where we had to minimize the LCM. So the first thing what we can see clearly is LCM starts repeating after n by 2. Till the number n by 2 the LCM is same 1, 2, 3, 4 and 5. I mean till before n by 2, and after n by 2 the LCM starts repeating. So we have to just look the from I equals to 1 to n by 2, we just have to look the minimum LCM. That's the thing. And second thing is we split the number into a and b. So the value a can take is 1 and b can take is n n minus 1, and it goes on, and then a takes 2 and b takes n minus 2 till n by 2 this happens. So the value of a goes till n by 2. Then from here we can set some lower bound for b, where b is always less than equal to n minus 1, and also b is always greater than equal to n by 2. As a is less than n by 2, I is less than equal to n by 2, then b will also be greater than or equal to n by 2. This is the These are the two bounds which are set on b. Now what do we have to do is a plus b equals to n. We have to minimize the LCM of a comma b. Now when we iterate through a and b, like suppose we are iterating through all the values of a as well as b, we'll get two cases where b modulo a equals to 0 and b modulo a not equals to 0. When b modulo a equals to 0, our answer will be simply the LCM of a comma b is always b. You can just try doing it. LCM of, like, suppose take any number 2 comma 4. The LCM is always 4 here, or else maybe just you can just try. There are different proofs for it. A comma b, suppose this is a and this remains 1 and this goes as b, and there is some factor which divides it, then we'll get as 1 comma 1, 1 comma 1, then a into f will be the LCM, which is nothing but b, because a by b equals to f. I mean b by a equals to f. So a into f is nothing but b. So by this we can say that LCM will always be b, and if b modulo a not equals to 0, then LCM is 2b, 2 times b. Also our n is, the constant n is 2 to 10 power 9. So we cannot even iterate I to n by 2, because that will exceed the time complexity. We cannot do it in O of n time complexity. We have to look for a better time complexity. But till this point, it should be clear that we will always prefer b to be divisible by a, so that we can minimize our LCM. And that will surely happen because the constraint which are given to us. So we start initializing a by 1 and b as n minus 1. How, and yeah, LCM will be 2b. How will it be 2b? Because LCM of a comma b is always a into b when both are not divisible by each other. And here 1 is divisible by b, so we consider it as this case. And if we set a as 2, then we'll get LCM as 2 into b. So this will be lower bound to our LCM. This thing 2b is lower bound to our LCM. It's not necessary to be equal. This will be a lower bound to our LCM. Yeah, so but the b is better than 2 into b. So this will be the shortest element which we'll be preferring. Now our aim is to find a and b, and we have to minimize the LCM. To minimize the LCM, we have to minimize b. To minimize b, we have to maximize a. So we'll be deducing these conditions. First thing is b modulo a equals to 0. This is the first condition. And second condition is that we have to minimize b. For that, a should be maximum. From this condition, what we can conclude is n modulo a is also equal to 0 because n is nothing but a plus b. N modulo a equals to a plus b modulo a, which is nothing but a modulo a plus b modulo a plus a modulo a by the modular arithmetic, which will be giving us a b modulo a. So this is the main thing. Now if we iterate from I to I equals to 0 to n, I mean 1 to n minus 1, we have to look for numbers which give us n modulo I equals to 0. Hmm. So rather than iterating 1 to n minus 1, we can iterate from I equals to 1 to square root of n. That's the better thing. Because if you look closely, suppose there are number 1, 2, 3, 4, 5, 6, 7, 8, 9. Square root of 9 is somewhere here 3. So if we iterate till here, it's sufficient for us to find factors which are minimum. Suppose we get a as the factor, what we need to do is maximize a. To maximize a, simply we can set a is equal to n by whatever the number which we get on our iteration n by I. This looks a bit complicated to explain as well, but I'll try my best. So we iterate from 1 to 3 here. Suppose for this case we'll be having 3 as a factor. Suppose we got 3 as a factor, then on this side what we'll have is n by I as the factor. I mean 9 by 3 will be our another factor, which is 6 here. So till root n is sufficient, as if we get any factor here, the on the other side we get n by with the I mean the whole number divided by that I, which will be the another factor. Suppose I write down numbers till 16, 6, 7, 8, 9, because that's another perfect square, 13, 14, 15, 16. So I have till here 4. 4 is one factor, 2 is one factor, even 1 is also a factor. If 1 is the factor, then 16 by 1 will be another factor. We'll get a counter part of it. And if 2 is a factor, then 8 will be the factor because 16 by 2 is the factor. 16 by 2 is nothing but 8. And obviously 16 by 4, which is nothing but 4. So 4 and 4 itself are counterfactors. So it's just sufficient to iterate till 10 power, I mean root n. And also we can minimize our constraints as big of like root of 10 power 9 is approximately 10 power 5. So this will get the work done without giving a TLE. That's where the factors end, because remaining we don't get any factors for 16. Within the root and range we'll be getting the factors. Now suppose if we get a number I, suppose let's play with this example only. I got 2 as a number. Now what I want to do is I want to maximize the value of A. To maximize the value of A, I'll simply set A as n by whatever the value of I which I got, which is divisible by n. I will set A as n by I. Means what? I'll set A as n by 16 by 2, which is 8. That will get the work done. So that my B will be 16 minus 8, which is, no, not 16 minus 8. Yeah, it's 16 minus 8, sorry. 16 minus 8, which is 8. That's the minimum LCM if you check. What did you use here is 9. If we do till 9 here, then we'll get 3 as a number and 1 as a number. What we'll do is, like, he'll get only 1 and 3, where we'll get LCM, and also as well as they're divisible by each other. So if we go for 3 and 9, if we go for 3 and 9, then We can set A as simply A is equal to 9 by 3, which is equal to 3, and B is equal to n minus 3, which is nothing but 6. Those two numbers will get the work done for us. So then we'll try implementing it by the code. Maybe the code might get the, it might make easier to understand. First of all, let me just parse it. This rule will satisfy for all the constraints. If you check for one also, for check for n equals to 2, it will pass the same thing. Now what I'll do is int a comma b. I'll set a as 1 and b as n minus 1. Now I'll start iterating for int I equals to 2. I'll I into I less than or equal to n. This is good for iterating in square root of n complexity, and then I less than or equal to square root of n. That's also preferable, but and that's not much preferable, but that might work as well. You just need to work with the data types, float or integer. Then what we can do is, if n modulo I equals to 0, then I'll set a as n by I, because that will be the greatest value of a possible, and b as n minus I. This will be giving us the minimum value of LCM, minimum possible value of LCM. Now some people might get a doubt, why don't we put b as I? We can put b as I, but we'll get the same. I mean, if you put b as I, then a will be n minus I. That won't give us a minimum LCM, because if you look at this example, let's say if I put b as n minus I, and if I keep n as 16 and then put b as I, let's say the value of I, if we say b I is 2, 2 and 14, 2 and 14 won't give us a minimum LCM. We'll get 14 as the LCM, but 14 won't be the minimum LCM. So what we have to check is n by 2. N by 2 is 8. 8 and 8 will obviously give us a minimum element, minimum LCM. So that's good to go. See out. A. Yeah, this might work now. Hmm, 5 comma 8. Maybe there's an error with this test case for n equals to 10. Maybe I have made mistake somewhere. Let's verify with the editorial. What did he do? Yeah, he did the same thing. A is equal to n by I. 2 and 4 less than equal to 10. If we choose 10 as the number, then it will go for 2 and 3, 2 and 3, 1, 2, 3. So 10 modulo 2 equals to 0, a equals to 10 by 2, which is 5, a is equal to n by a, break, c out a comma n minus a. Now let's try with this. Yeah, and got passed. Well, I think there was some mistake happening there. Okay, okay. I needed to put here n minus a, not n minus I. That was the mistake which I did. Anyhow, let's proceed with this. 1, 2, 3, 4, 5, 6, 7. After 7 wrong submissions, finally this question got accepted. Well, let's go with the next question. I'm solving this question from the CP sheet provided by TLE Eliminators. You can check out. I think there are really good questions for practicing here. Okay, we'll start with the traffic light question. You find yourself on an unusual crossroad with a weird traffic light. The traffic light has three possible colors: red, yellow, green. It is known that traffic light repeats its color every n seconds, and ith second the color SI is on. That way, the order of color described by string. For example, if S equal to RGGY, then the traffic light works as following: red, green, green, red, yellow, red, green, green, red, yellow, and so on. More formally, you are given a string of length n. At the first second color S1 is on, the second S2 is on, and nth color the Sn is on, and at the n plus 1 second S1 is on, and so on. Okay. You need to cross the road, and that can be done only when the green color is on. You know which color on the traffic light at the moment, but you don't know the current moment of time. You need to find the minimum amount of time which you are guaranteed to cross the road. You can assume that you cross the road immediately. You know which colors, but you don't know the current moment of time. You need to find the minimum amount of time which you are guaranteed to cross the road. And the current there two option green car after 1 second, after 3 seconds. That way answer is equal to the number that we are guaranteed to cross the road if the current color is R. Minimum amount of time in which you are guaranteed to cross the road. You know which color is on the traffic light at the moment, but you don't know the current moment of time. You need to find the minimum amount of time which you are guaranteed to cross the road. Okay, so either we can be at the red color, or either I can be at the green color, or I can be at the red color. We don't know at which color I am. For example, the current color are there are two options. Either green color will be on after 1 second or after 3 seconds. Okay. So suppose if I'm on color R, then either after 1 second I'll get the green color, or else suppose if I'm here, then after 1 second, 2 second, and after 3 second I'll be getting the green again. Current is R. Okay. If the current second is yellow, then there will be like 1, 2 seconds and 3 seconds to cross. Let's see more test cases where we'll get more amount of clarity. This is the amount of test cases, then value of n, and symbol C. C is one of the allowed traffic light colors. Did you mention C here? Only one green color. Okay, okay. R by G symbol. Okay. And symbol G is in stringers and symbol C is in the stringers. Well, minimal second which are guaranteed to cross the road. Okay, it's a easy question. They just gave a long problem statement for us to read, but it can be done easily. When the constraints are not too bad, they're like okay, okay. We can go in linear time complexity. First test case is explained in this segment. Okay, here it is 0. So if string will be G, then always answer will be 0 because I can cross the road at that moment of time. Or else R G minus R, G minus R. The first test case will be sufficient to even encounter the edge cases where we have to again count from the string. First of all, this will be the length of string, then character C in C, then string S, C in S. If C equals to green, then it's 0 seconds, 0, and I'll return. Well, but if what if it is R? Then what we have to do is note all of the colors, I mean all the indices. Okay, let's go with this first test case R, G, G, R, Y. If we see the indices 0, 1, 2, 3, 4. So I'll be storing indices of R in one index 0, comma 3, and indices of G 1, comma 2. This is R and this is G. Now 1 minus 0 or 2 minus 3. We have to just make a general formula for this after repetition, so that then my answer will be done here. I can just go for the coding part. I need a general formula for 2 minus 3. 2 minus 3. This is green, this is red. I have to go here like in this manner. Then the minimum index I should encounter. Three, two. Hmm. If 2 is greater than 3, then I'll go for mapping to the minimum element. What I need is the repeated again the distance between 3 and 1, which is n minus 3, n minus 3 plus 2, 4 minus 3 plus 2, which is 3. Minimal number of seconds in which you're guaranteed to cross the road. You're asking number of seconds that we are guaranteed to cross the road. And then for that we need to choose the highest index some element, because then only we'll be guaranteed to cross the road. If I choose y here, yeah. If you go on, if I choose y here, then 1, 2, 3, 4. That will be the guaranteed time. If we start from the fifth second, so we have to just start from the maximum second. Here 1 second will be the minimal amount of time, and here again once 1, 2, 3, 4 will be the answer. One indirectly, I think he's asking us to print the maximum value. The third test case, red color was on at the second. If you will wait for green color for 1 second, and if the red light was on first second, then we will wait for the green light for 2 seconds. I guess he's asking the maximum answer indirectly. So it's nothing but n minus the index plus the least index of green. You have to maximize this thing. If 2 is greater than 3, then suppose this is 0. Then if I want to reach out green here, these are the indices of red color and these are the indices of green color. 1 comma 2. We are just bothered about elements where the gi is less than ri. Then how can we need to get the value of this thing? 3 comma 2. See, gi is less than ri over here. Then for this thing also, no, not for this thing, but for this thing we need the now we need a general formula. N minus gi 4 minus 2, no, not 4 minus 2, 4 minus 3 ri, n minus ri, 4 minus 3 is 1 second, plus the minimum of gi plus minus 1, because we are using a zero based indexing. This will be the final formula. Suppose here 4 minus 3 plus 1 minus 1, which is nothing but 4 minus 3 is 1 plus 0. No. The value of n is 5, not 4. But let's take as 4 instead of subtracting this 1. And minus, we'll do it one time. 4 minus 3 plus 0 comma 1 plus the minimum value 1 plus 1 again. So we'll have a plus 1 here. I think this will get the work done. No need to do this all. 5 minus 3, it is 2 plus minimum of green index, which is 1, which gives us 3. So which is n minus Ri plus minimum Gi plus 1. There will be one additional step, but if we take directly, and that will be covered. 5 minus 3 plus 1, just 3. This will be one thing. Hmm. Now what we have to do is minimize this thing. Overall, I mean the whole array. We'll verify the solution by taking another test case. Triple R, G, triple Y, GY. Now the target is Y. So we'll store all the indices of Y. 0, 1, 2, 3, 4, 5, 6, 7, 8. Y will be stored here as 4, 5, 6, and 8. And the indices of green will be stored here as 3 and 7. Now the condition is Gi should be less than Yi. I think this will go in n square time complexity. N is 9 over here. Hmm. So 9 minus 8 plus 3, which is 4. Then 9 minus 6 plus 3, which is 6. Yeah, it works somehow. Let's try this test case, third test case. R, R, G, where R is 0, comma 1, G is G is 0, 1, 2. Then what we can do is n minus n is now 3, I guess. Yeah, it's 3. 3 minus 3 minus Ri plus G. 3 minus 1 plus 2. 3 minus 0 plus 2. Uh, 3 minus 1 plus 2 and 3 minus 0 plus 2. It's 4 and here it's 5. But the answer says it's 2. Also, we have to take the positive distance 2 minus 1 comma 2 minus 0. We simply cannot go for one element. We cannot tell how will it happen. But after all, it matters is only the first index of green, which can be seen from all the observations. Where green is occurring only the first time. So G minus R1, G minus R0. Be setting a flag here. Then this will be the index of G, minimum index. And I'll set flag equals to 1. Mm, Now will if s of y equals to the target character, whichever is it, C, then T dot pushback I. Hmm. Now for and many equals to infinite 1e9, let's say, for auto IT V, the vector, sorry, it's T not V. If G minus IT, the distances G minus IT is positive, is greater than 0, then min is equal to mini equals to min of G comma mini. I mean G minus IT comma mini. That's the minimal distance which we need. Minimal number of second. What is meant by minimal and minimum? Or else we'll just maximize it. Or else, okay, we'll create two variables actually. Max is equal to min of max comma the formula which we created. Now out of this we have to print the minimum distance. If you go on minimizing, this will go till negative. We have to maximize it or minimize it. It's a bit confusing here. All we have to do is play with max, min, and this min. See, we got this thing here. Okay, I think we are done with the formalization of this thing. What we just have to do is have to check for the answer. This both cannot be negative if we look, because anyways I applied this condition. We have to maximize this and we have to minimize this. And after all, we have to print the minimum answer out of these. Thing is that we are getting minus 1000 here. But if we print maximum, we'll be getting a plus 1000. Let's just do it as mini of mini, then see out mini, and then that might work. Well,
Yeah. So where was I? So what did we have to do was we need the minimal number of seconds which we are guaranteed to cross the road. Mm. Oof.
all we need is the first index of G, and with that only we can do all the, I mean, we can get the answer from that. G minus IT greater than 0. And then we have to choose the maximum distance. Also, I think we have to choose the minimum distance among these all. Green color is on, so you can cross the road immediately. In the third test case, red color was on at second, then we will wait for green color for 1 second. And if the red color was on at the first second, then we will wait for green light for 2 seconds. Minimal number of seconds in which you are guaranteed to cross the road. Okay, more formally, it's not less than n plus 1 per second. Okay, you need to cross the road, and that can only be done when green color is on. You know which color of the traffic light at the moment, but you don't know the current moment of time. Okay, you need to find the minimum amount of time in which you're guaranteed to cross the road. You can assume that you cross the road immediately. Okay. The color there are two options, whether green will be on after 1 second or after 3 seconds. That way the answer is equal to the number of seconds that we are guaranteed to cross the road if the current color is R. What's wrong in choosing this R is, and this R, 1, 2, 3. If we wait for 3 seconds using this R, then also we can cross the road. That's the thing. And if I choose this R, then also I can cross the road. So out of this all, I need to choose the maximum time which I'll take to cross the road. Here if I take 1, 2, 3, and 4 seconds to cross the road, that will be sufficient, I think. Anyhow, we need to choose the maximum distance from all of the distances. This cannot be done in n square time complexity. I have to use all of the indices. If you look, -it plus g. Among these all we need to choose the minimum distance, and among these all as well, you have to choose the minimum distance. 414103. Let's analyze where did we go wrong. If you look at this example, then from this we'll get this as the minimum distance. 3014. Now we have messed up with some other test cases. 30123 RRG. Received output, expected output. Here he maximize the distance, he minimize the distance, and he just maximize the distance over here. Maybe I made some mistake in reading the question or understanding it. You find yourself on an unusual crossroad with a traffic light. It has three possible colors and is known as traffic light repeats its color every n seconds and at second the color SI is on. That way the order of color is described. Example, then traffic light red, green, red, yellow and so on. S1 is the first second is second and the color S1 is on. You need to cross the road and that can only be done when green color is on. You know which color is on traffic light at the moment, but you don't know the current moment of time. Means I can either be on this red color or either on this red color. You need to find the minimum amount of time in which you are guaranteed to cross the road. Means if I choose any color, I should be able to cross the road among the and I should find the minimum amount of time in that. This minimum thing is quite confusing actually because just we need to find the maximum among all the colors which we need to cross the road. Wait. Once. Hmm. Or it's right. G minus IT, G minus IT. Indirectly, uh, the last element and the first element should be able to do it. One, 3024. Okay, we have to just work with the last two test cases. If we go look here, we'll be getting as 1. I think we need a double for loop here to loop between all the green indices and well as the red indices. But double for loop cannot get the work done because if I even try to do the double for loop, it will go in over big of n square for sure. Mm, 1, 2. I think I have to brute force the answer. So the distance between, I have to find minimum among distance between the last target index minus last green index, and this is like this thing, or else first green index and the last red index first, or else I mean the target index, last target index, or else last green index and yeah, among all these four combinations, last green index, last target index, first target index and first green index. I just need to look the minimum answer among these. No, I think this also doesn't work. Or else I have to go for the both arrays where I'll be storing the target, and in another array I'll be storing the index of the green. So this is the green array. Wait a minute. So first I'll be storing the green indices in one vector, and I'll be storing the target indices in one vector. Then what I'll do is, suppose the example is R G G R Y 0 1 2 3 4, and then we'll work with the test case, the last second one, R G R G Y R G. This is 0 1 2 3 4 5 and 6. So and in both the cases we have target as red. Then 0 comma 3 is will be stored here, and what about green? 1 2 comma, yeah, that's it. Now if green is greater than the target, then I'll be adding 1 minus 0. This adds up in the distance. And if green is less than the target, then what I'll do is n minus it plus 1. That's the thing which I have done here. Or else n minus it plus the index, whatever the g index, which is, so 1 minus 0 comma, what is in here? It is 5 minus it star 3 plus 2. 5 minus 3 is 2, 2 plus 2 is 4. Wait, n minus it plus g, n is 5, 5 minus the target index, 0 1 2 3. Not 2, sorry, 1 will be here. I mean the first g index, let's denote it as gf, the first g index. So I think that's how we have to do. Then after all we have to maximize the answer over all this. G minus it is greater than 0, then I'll be selecting m as maximum of m comma g minus it, else m as maximum of m comma n minus it plus gf. That's, I think, how it will be done. Let's just try it. If this didn't work, we'll go for looking to the editorial. I'll be back in a minute once. Yeah, I'm back. So if you try making two arrays where I'll be storing the indices of g and index of t, it won't be possible for me to track them also using the for loop. Let's check the editorial. Let's know that for each color second. Yeah, so Let's note that for each second of color see in the traffic light, we need to find the rightmost green time and then find the largest distance between color C at the nearest green. Also, let's not forget that traffic light states are cyclical. To get rid of cyclicity, you can write the string as twice, and for each cell of color C from the first half, each cell of color. Okay, that's a good thing. We have to write the string as twice. Color C from the first half, find the nearest green color, thus we solve problem with cyclicity. And now we can just follow this line from right to left and maintain the index of last occurrence of green. If we are not encounter color C, we try to update our answer with maximum, where answer is our last nearest time that green was only color and I is equal to current time. Okay, yeah, well, we'll try with this approach. That's a like quite good approach. I think I was stuck for in this problem for more than half an hour. So I felt like reading the editorial after all. So I'll create another string str and str equals to s. I think is it possible? Okay, str dot append s cout str. Let's just verify what did we do here. Okay, well, now what we will do, we'll run a reverse for loop. Int of last g equals to -1 for int I equals to n minus 1 I greater than equal to 0 I minus if s of I equals to green, then last g equals to I, then what will do else? If si equals to the target, I mean str not s, and I think it will be 2n now, 2 into n minus 1, the target string, which is c. Then I'll just update it. Last g equals to maximum of, wait, not last g, but that will be my answer. And answer is equal to -1. So now answer is equal to maximum of answer comma last g minus I. I think it will work now because if we go on decrementing, then if the answer will be maximum, then only it is guaranteed to cross the road, because any target, with the help of any target color, we can cross the road. So just our aim is to make the answer maximum. We just give the thing, mention the keyword minimum just for confusing us. Last g minus I, suppose it got decrease, I goes on decreasing, so there's no problem in this. Okay, so well, I guess that's the final answer. Okay, fine. This question somewhat took time, even to just think about the approach. Maybe it will take too much time for me to improve in this thing. Okay, well, and then so out of 31 questions, we are done with around 10 questions. So we'll be continuing these both in the next video. Let's just see what is this question. Basketball. We'll just read this question. If it looks somewhat easy, I'll continue it, or else then I have to end this video here. Competition number of players does not have maximum minimum limit. There are non-candidate players. Competition between the best basketball coach on earth. Vaccine from joined to most one team. Each of them sent to compete and you can win each match and defeat the army. Some of our form players and same form match change of problem play. Basketball competition is held when number of players in team does not have maximum or minimum limit. Not necessarily 5 players in one team for each match. And there are n candidate players in the competition that will be trained. The best basketball coach on earth, the eighth candidate power as PI. Okay. Park Chan-wook will form zero or more teams from the uh, n candidate players on condition that each candidate player may join in at most one team. Okay. Will join zero or more teams from the n candidate players on the condition that each candidate player may only join in at most one team. Okay. Each Park Chan-wook's team will be sent to compete once with enemy team that has power of D. In each match, the team is sent to set to defeat the enemy team if the sum of power of the form player is strictly greater than D. Okay. When the team that has been formed plays in match, he can change the power of each player in the team to be equal to the biggest player power from the team. Okay. Maximum number of minimums that can be achieved by Vakchanik. I think is asking number of ways to select those players and number of candidate players and power of enemy team, power of all candidate players. First team form containing of players 4 and 6, power of each team. Each player becomes 100, so the total power of team is 100 plus 100, 200 greater than 180. Okay. Team containing players 1990, so the total power is 270. The total power should be greater than this thing. Zero or more teams and one candidate players on condition. Teams, either zero team or one team from the one condition that each candidate player may only join in at most one team. Team will be sent to compete once with an enemy team that has power of the match. Team is sent to defeat an enemy team. Sum of power of one form plays in match. Why can you not choose like three players 80 80? I mean four players of strength 80 and like four players of strength 50. That will be more better. Candidate players that each candidate player may only join in at most. Zero or more teams from the n candidate players on the condition zero or more teams and that zero team or one team from the n candidate players on condition that each candidate player may only join in at most one team. First team is formed is a team containing player 4 and 6. 1, 2, 3, 4, 5, 6. Power of each player in team. So the power, okay. So what he can do is he can change the power of each player in the team to be equal to biggest player power from the team. Change power of each player to be biggest. This question is quite complicated. Park Chanek will form zero or more teams from the uncandidate players on the condition that each candidate player may only join in at most one team. Each of Park Chanek's team will be sent to compete once with enemy team that has power of D. In each match, the team sent is each of the Park Chanek's teams will be sent to compete once with an enemy team that has power of D. In each match, the team is set to defeat the enemy team if the sum of power from the formed player is strictly greater than D. Okay. Team sent is set to defeat the enemy team. The first team sent is the power each player becomes the total power of team is 100 plus 100 200. The power each player becomes 90. So the total power is 270. 1, 2, 3, 4, 5. Maximum number of wins. I'll be back in a minute.